For code analysis, we'll be using advanced static analysis tool called IDEA Pro. IDEA Pro allows us to take a look into the malware by allowing us to load a malware executable file into the program. It will display information of the malware in tabs such as IDEA view, functions, and imports.
So first, we will be looking at the start of the program, start of the malware. So it will call two subroutines, which is 40dd25 and 40ead3. So first, we will be looking at some network-based indicators, which is in the imports. And the first network-based indicators will be internet read file. Okay, what does internet read file do? It reads a file from the internet, of course. So when we look at the graph, there are two subroutines that is making use the internet read file function, which is first the 40A1BC and 40A75. So we will look at 40A1BC. Okay, so there are a few parameters in the 40A1BC, which is the IP option, argument list, and a few ints. So there are local variables like hinternet. There is going to be a network-based indicator, which is quite significant in this subroutine. And okay, so first there is a internet open A, which is opens an internet proxy, as you can see from the proxy and the bypass and access type. And internet canonicalized URL, internet connect A, HTTP open request, and there is a post request to the HTTP open request. So as a result, you can see that this subroutine is most likely a post request, which is uploading the data into the web. Okay, so there are functions like HTTP send request, HTTP query info, internet read file, which is the functions that we want to look at, internet close handle. So by far this is the close handle, and this will be the functions that is in the subroutine. So as a result, we can see that this subroutine is to upload data into the web. So the next subroutine we will look at is the 40A75. Okay, so there are a few parameters, which is the LPC string, H internet, and IPSZ headers. So there are functions like internet open A, internet canonicalized URL A, internet connect A, HTTP open request, HTTP send request, HTTP query info A, internet query data available, internet query data available, internet read file, and internet close handle. So most likely this subroutine is to have a request to the web and get information from the web. Okay, so the next network-based indicators we'll be looking at is the create remote thread. So the create remote thread is being used by 40AFD4. So we will look at the subroutine 40AFD4. 40AFD4 AF74. 74. FT4. Okay, so there are handle processes, thread ID and H process for the local variable. So what does this subroutine do? When there is an error, it will just call get module handle, and if it successfully test this AL and AL, it will go to the create remote thread. It will start create a remote thread to the network.
Okay, for the host-based indicator, we'll be taking a look at the first notable function, which is remove directory A. Remove directory A is provided by kernel 32 in the DLL library. Remove directory A is being used by this subroutine called 40D359. 40D359. This subroutine will be taken a look at in order to find out why is it using remove directory A. It takes in from this view, we are able to see that it takes in an attribute lpcstr lp_string2, which is a pointer to a string, and it uses methods such as create process A, which we've loaded all the attributes. From this, I can tell that the malware is trying to create its own process. If it fails, it will try to delete its existence by using wait for single object, close handle, delete file A, sleep, exist process, and remove directory A. Then after that, once it deleted its existence from the directory, it will start to create a new handle and start the process all over again. Once it has finished writing all the attributes, it will start to flush the instruction cache with its instructions, and it will close handle to end the process. From what I can tell, the malware used this subroutine in order to create a process to put files with attributes, and if it fails, it will try to remove its existence by using the remove directory A functions. The second function that we'll be looking at would be create file A. This is also provided in the kernel 32 DLL file library. From the graph, we can see that there are two subroutines that use this method. Subroutine 40CFA1 and subroutine 40D05A. So subroutine 40CFA1 takes in three attributes: lpcstr, dword, and integer. These three attributes are taken in, and there are four local variables. The methods used in this subroutine is such as create file A, create file mapping A, close handle, and map view of file. With all the related attributes that are passed in from the bred in by the subroutine, I can infer that this malware is using this subroutine to create a file and placing it in a specific directory using create file mapping A. Hence, in this context, create file A is being used to create a specific file to be placed at a special location. The next subroutine that uses this function is 40D05A. It takes in three attributes: handle H object, lpcstr, which is a pointer. These two attributes and 5 local variables are being used by this subroutine. It contains methods such as create file A, get file time, set file time, and close handle. Create file A it tries to create a file with all the particulars and compares to the directory. If it fails, means the file is non-existent, and tries to put in and create a file using create file A with all the specific attributes. After it's being created, it compares again to see if it can be placed in. If it fails, it starts to get file time and sets a new file time in order to make it work, and it will close handle once it's able to succeed.